Today we're going to learn about parametric equations. One thing that you would hear me and teaching you about this say over and over again is parametrics plot points. Points are given as ordered pairs, x, y, and parametric equations are always x equals and y equals, and we use what we call a parameter to determine the x and the y coordinate at a certain, the easiest way to talk about it is at a certain time t, and we use t as the parameter, it's called. So in the first example I'm going to show you with that is I'm going to say x equals t squared minus 2 and y equals 3t. And we're going to say that t, the parameter, is going to range from -3 to +1. So for this example, we're going to make a table of values, and we're going to let t be the smallest value, -3. And if t is -3, you would plug a -3 in for the t here, and it would be -3 squared is 9 minus 2 is 7. So x would be 7. And you plug a -3 in for t here, and y would be -9. So x would be 7 and y would be -9. So that means that the ordered pair 7, -9 will appear on the graph. Then we plug in a -2 for t. -2 squared is 4 minus 2 is 2 for the x coordinate. And when we plug in a -2 for t in the y equation, 3 times -2 is -6. So the y coordinate is -6, which means we would plot the point 2, -. Then we plug in a -1 for t, which would make x coordinate 1 minus 2, which is -1. 3 times -1 would be -3. We plug in a 0 for t, and that would make 0 minus 2 is -2 for the x coordinate. 3 times 0 is 0 for the y coordinate. We'll plot those 2 points. Now we'll plug in a +1 in for t. X will be -1 and y will be 3. So we plot the point -1, 3, and that completes it. So if you were to plot this on your graphing calculator, these are the points that are plotted using just the integers for t, -3 to +1, but we could have also plugged in fractions in between all those numbers. So this would end up being a smooth curve that would go in this direction. It would plot just like that on your calculator in that direction, starting here at 7, -9, and finishing at -1, +3. We're going to now look at the same parametric equations, but we're going to change the parameter now to t between -2 and +3. So we'll start here at -2, it's the same equations. We'll go to 2 and also to 3 for the t value. If we plug a 2 in for t, x will be 2 squared, which is 4 minus 2 is 2, and y will be 3 times 2 is 6. If we plug a 3 in, 3 squared is 9 minus 2 is 7, and 3 times 3 is 9, so we'll add those points. We'll now plot those points on the graph. So we plotted those points. Again, we would start at 2, -6, and we would plot this smooth looking, looks like a sideways parabola going in that direction. But you can see that it's basically graphing the same thing. It just stops at different places. And if we would have graphed it, with the parameter from t greater than or equal to -3 and less than or equal to +3, we would have just simply added that first point up here at the top right here, and the 0.7, -9 would be plotted, and that's where we would have started, and it would have just added that to the graph, and then it would have continued on all the way to the end when t is +3. So I hope you've got an idea that parametrics plot points. You plug a value in for t, it tells you the location of the point at that particular value for t. And it just continues to plot the points as it go around. Now I'm going to show you how to eliminate the parameter on a set of parametric equations and just turn it into a Cartesian equation that you would have recognized. So here we go. Our parametric equations are given here. To eliminate the parameter, we simply solve for t in one of the two equations. You can solve for either one. I'll show you what would happen if you did it for either one. So let's take the x equation and we'll solve for t. So x minus 1 would equal -2t. T would equal x minus 1 over -2. So now we're going to take that value and we're going to plug it in for t in the y equation, which will give us a new equation, y equals 2 minus, and instead of t, we'll substitute in x minus 1 over -2. Let's simplify that. That'll be really 2 minus, we can say, a -1/2 times x minus 1, which will be 2 plus 1/2 times x minus 1, which is 2 plus 1/2 x minus 1/2, which is 1/2 x plus 3/2, which you would recognize easily is a line, the slope of 1/2 and a y-intercept of 3/2. Another way to do it would have been to solve for t on the second equation, which was y equals 2 minus t. Here t would equal 2 minus y. You could take that 2 minus y, plug it into the x equation, and for t, so it'll be x equals 1 minus 2 times 2 minus y. And that would give us x equals 1 minus 4 plus 2y. And x would equal -3 plus 2y. X plus 3 would equal 2y. And y would equal positive 1/2 x plus 3/2. And that's another way of getting to that answer. It didn't really matter which way we did it. Okay, we're going to do another example where we're going to eliminate the parameter. This one's a little more complex than the last one, not really too bad. It's just not going to be a nice little line. So the easiest equation to solve for on this one will be the y equation. If we solve for solve for t with the y equation, t would equal y over 3. We will take that y over 3, substitute it in for the t value in the x equation. So x would equal y over 3 squared minus 2. We'll continue to simplify. X equals y squared over 9 minus 2. And I'm going to finish up writing it this way, 1/9 y squared minus 2. And I imagine you probably don't like the looks of that very well. Instead of y equals, it's x equals. But all this means is it's going to be just like y equals 1/9 x squared minus 2, only this thing is going to be a parabola that will open to the right instead of opening up like it would be if it was solved for y. It will have a vertex at -2, 0. And it's pretty easy to see how this is the way I said it. If this would have been an equation solved for y, you would easily know that this is a parabola that opens up, has a vertical shrink of 1/9, and it's shifted 2 down. Well, we just transfer that. Instead of going up and down, we're going to go left and right, and we know that right is positive, left is negative. So we know that this parabola opens to the right because the leading coefficient is positive. We know that it's a horizontal shrink of a 1/9 instead of a vertical shrink. It's also going to be shifted 2 units to the left instead of 2 units down like it was when it was solved for y. So it's not too bad. If you would have chosen to solve for t with the x equation, it would have been a little bit harder because it would have been x plus 2 equals t squared, and then t would equal plus or minus the square root of x plus 2, which then you would have to put into the y equation and get 3 times, and it would be plus or minus 3 radical x plus 2. Now, that one, you probably know what that looks like pretty easily. It's a square root graph shifted 2 to the left, and it's going to have a vertical stretch of 3. The positive square root, 3 times the square root, would be like this. The negative square root would be like this. But that's exactly what we described over here. We said that this one was going to have a vertex at -2, 0. And we said it was going to open to the right. And the same thing would happen. You would basically get a parabola like this. Here we're going to try to put the parametric equations into a Cartesian equation. The problem with this, if you were to solve for t, the first thing you would do is you would take x over 3 equals the cosine of t, and then to solve for t, it would be the inverse cosine of x over 3, and then you'd have to plug it in for t here and get 3 times the sine of the inverse cosine. Well, that's a mess. So we're not going to do that, but we are going to isolate the cosine of t. Same thing with, we're going to say y over 3 equals the sine of t. And then we're just going to use a little trick, and that's a Pythagorean identity. Pythagorean identity, cosine squared plus sine squared equals 1. And since the cosine is x over 3, that means it's going to be x over 3 squared plus y over 3 for the sine of t, and it's squared, equals 1. When we square it out, it's x squared over 9 plus y squared over 9 equals 1. And we end up with x squared plus y squared equals 9, which we all recognize to be the equation of a circle with a radius of 3. And the center is at 0, 0. So a circle with center 0, 0, and the radius equal to 3.